Hi friends, we are still in chapter 6 and we're looking at systems of linear equations, and today we're going to talk about something really interesting and kind of weird. We're going to talk about using matrices to solve systems of equations. So definitely follow along and please make sure you take notes. All right, so let's look at some of the vocabulary. The first bit of vocabulary that we have is the use of the term augmented matrix. It's a matrix that consists of coefficients and the constant term of a linear equation, and it is used to solve systems of linear equations. So if you were to have the equation, let's say 2x plus 3y equals 7 and 4x minus 9y equals 2, the way you would write an augmented matrix for this is you would simply, first of all, you want both of the equations in standard form, and what you do is you just pull off the coefficients. And then the constant, we put a little bit to the right of a dotted line. So we'd have 4, -9 here, and 2. So this is an augmented matrix here, and this is what we're going to use to solve systems of linear equations. And the next thing that we need to talk about is row reduction. It's a process of performing elementary row operations on an augmented matrix to solve the system. So basically what this calls for, these are going to be the rules that we're going to use to manipulate said matrix in order for us to come up with a solution. And one really important concept that we need to keep in mind is something that you'll talk about later on, but like in high school, but the identity matrix, which is a really important matrix. The identity matrix is an n by n matrix, meaning it's a square matrix, and basically it has ones along the diagonal of the matrix and zeros everywhere else. So an example of an identity matrix, an identity 2 by 2 matrix would be this. An identity 3 by 3 matrix would have ones across the diagonal, and as I mentioned before in the definition, zeros everywhere else. So what we're going to do is use these rules that we'll talk about to manipulate the augmented matrix. And the manipulation we're going to do is to make sure that this leftmost part is an identity matrix, and that's going to give us the solution. So let's see how to do it. So example 1. First thing I need to actually do before we actually do these examples, well, this is going to be pretty simple, so we can do it. But I really do want to spend some time really talking about the rules, like what's legal in this little manipulation. But here, in example 1, all we're doing is writing augmented matrices for each of these situations. So as I mentioned before, you want to make sure that they're in standard form, and both of these equations are. So let's call this one like part A. So example 1, part A, we're going to write an augmented matrix, and again, it's pretty simple. You're going to write the coefficients of each x and y term exactly as they appear in the two equations, and the constants go on the other side of this dotted line. So success, we did it. Let's go ahead and notice that the -4, we have a -4 here, -2, so you want to make sure that your signs are in line. I did say, let's call this one part B, I did say that we wanted to make sure that when we were doing this, we had them in standard form. And we know standard form, back in the day, here's a little thought bubble, standard form is AX plus BY equals C. And so we want to make sure when we're looking at our equations, they're in standard form. So I've got X minus 2Y is equal to 5. Clearly that's standard form. But one might look at this and say, well, this isn't standard form. I don't know what it is. It is standard form because we could look at this as 0x, right? Because there's no x's here, plus y is equal to -4. And sometimes rewriting it, forcing it into standard form makes you feel more confident about actually putting it, creating the related augmented matrix. So here we have the coefficient of x is 1, not 0, as sometimes we like to do, just because we don't see a number there, but the coefficient is 1. We get a -2 here and a 5 here. In the next equation, we have 0 as the coefficient of x, 1 is the coefficient of y, and -4 as the coefficient, as the a constant term, pardon me, as the C term. And so we're done. So that was all we needed to do for this first example. Let's take a look at the next example. So for this example, we're going to have to actually solve. The first step, and I'm going to write down some rules, so this is going to be really important for us. Okay, so I've taken the time to write out these rules and I want you to think about them as we're moving forward. I'm going to go through them. So what we're going to do is we're going to make an augmented matrix. You guys already know how to do that. And our goal, as I mentioned when we were talking about the vocabulary, is to take the first part of that augmented matrix. Here it is. Here it is, our matrix. And what we need to do is our goal is to make sure, and I'm going to do it in an orange color. Our goal, eventually, we want to get down to the place where we have, this is going to seem weird, an identity matrix 1 0 0 1, okay? And then we'll get some answers here. We'll get two values here once we do all this manipulation to get down here. Let's think about what this means real quick. What this means, remember this column referred to like our x terms, right? This column here refers to our y terms, and this column is our constant. And I shouldn't say x terms, our x coefficients, our y coefficients, and our constants. That's better. So if my x coefficient is 1 and my y coefficient is 0, in essence, I get x with no y is equal to something. So this row is going to solve for x. Okay? Once we do this, I know I haven't told you how we're going to do it, but if I could manipulate this thing into this thing, if I can manipulate this part of the matrix into an identity matrix, I am in essence solving for x, because the coefficient of x, like I'm creating an equation where the coefficient of x is 1, the coefficient of coefficient of y is 0, and then all of that is equal to this thing here. And then finally, with the coefficient of x in the second equation or second row is 0 and the coefficient of y is 1, then whatever I get over here is going to be the solution for y. So the second row solves for y, okay? So how do we do it? We got to use these rules over here. So here are the rules of the game. I actually like thinking about it as a game. And real talk, there's more than one way to win the game. There's more than one way to handle these problems. But here are the laws that we can use. The first is we can switch any two rows to make it convenient to get this thing here. We can multiply a row with a non-zero constant, and that's totally legal. We haven't changed the value of the problem. We can replace one row. Now this is the one that I think a lot of people might get a little confused about or caught up on. We can replace a row with the sum of that row and the multiple of another, meaning if I multiply one row and I can multiply one row by a number added to the next row and replace that row that I added it to. And you'll see us do this in the next two examples, so have no fear. I'm going to leave these rules up here. I think it would be wise if you copied it down. I'm going to shrink it a little bit so it's out of our way, so we can have some room to play the game, all right? So what I'd like to do here is get started manipulating this equation. So in addition to moving our rules over here, I also moved our goal up here to give us some space down at the bottom. So here's the deal. Our goal again is to get the identity matrix. How do we do that? We're going to use our rules. So here's the first thing I'm going to do. I recognize that I really want 1 up here in my first column, right? I really want that. So the first thing I'm going to do, the first step I'm going to use is I'm going to use my ability to switch the two rows. So the first thing I'll do is I'm going to switch and put 1, -1, 4 at the top, and then -5, 3, and 6 at the bottom. So I've done the first thing, I've switched. And so I have a 1 here, which makes me feel good. What I need to do next is, I could try to get a 0 here, but I think I'm going to get rid of this 5 and get a 0 here. I think that might be easy. So the way I can get a 0 is basically I'm going to use rule number 3. Rule number 3 says that I can replace a row with the sum of it and the multiple of another row. So I'm going to leave the first row as it is, 1, -1, 4, and then I'm going to replace this next row by multiplying my first row by a +5 and adding it to the second row. So watch what happens. 5 times 1 is 5. When I add -5, I get 0. 5 times -5 is -5. When I add 3, I get a -2. 5 times 4 is going to give me 20. 20 plus 6 is going to give me 26. So I'm getting close to my goal. Notice I have a 1 and a 0, and I've only been following my rules here. Having this 1 and 0 is going to be super helpful for me because now I want to make this a 0 as well. And in order to make this a 0, I'm going to have to figure out how to find a way to add, like get the additive inverse. Now, when I look at this -2, adding it to -1 or multiplying it by something, I totally think I'm going to have to use a fraction. Is that legal? Totally is. Not really in the mood for it. So instead of going to make this a 0, I'm thinking it might be pretty easy to make this 1. I can make this -2 a 1, as is my goal. I don't want you to forget that. I can make this -2 1 by using rule number 2. I'm going to multiply a row with a non-zero constant, right? So that means I can multiply by any old number I want as long as it's not 0. So here's my goal. I'm going to leave this first row as it is for now, right? Let me get my pen. I'm going to leave the first row as it is for now. So I'm going to rewrite that 1, -1, and 4. And what I'm going to do is multiply this second row by a -1/2. Technically, I'm dividing by -2, if that makes sense. So if I divide 0 by -2 or multiply by -1/2, I still get 0. That's not affected. If I divide this guy by -2 or multiply by -1/2, I get a +1. If I divide this guy by -2 or multiply by -1/2, I'm going to get a -13. So you see I'm really on my way. 1, 0, 1. The next thing I need to get is a 0 here. Now that I've handled this is really easy to get the 0. Honestly, I can just add up the values as it is. So what I'm going to do is I'm going to leave the bottom row as it is, 1, 0, and this -13. And then I'm going to take the top row and I'm going to add them together as they are. So 0 plus 1 is 1. 1 plus a -1 is 0. -13 plus 4 is a -9. And I have found success. I have the identity matrix, which was my goal. And as I mentioned before, ultimately, we made an equation where the coefficient of x was 1, the coefficient of y was 0. Therefore, x is equal to a -9, given this equation. And clearly, we can continue that by saying, well, if the coefficient of x here is 0 and the coefficient of y is 1, then y is equal to -13. That's kind of cool, right? I'm going to go back over this because I do want to talk about what we did because I know it is kind of crazy. So in blue, I'm going to kind of give us directions as to what we did. First thing we did was rule number 1. So I'm going to put rule 1. Rule 1 was the switch. We did the old switcheroo. The second thing we did here, how did we get this? So we left the first row the same. And what did we do with the second row? Oh, I'm going to put rule 1 here. I'm sorry about that. We used rule number 3, which gave us the opportunity to do what? Multiply one row. So I multiplied the first row by 5 and I added it to the second row and I got this replacement row. Okay, so I did rule 1 here, rule 3 here. How did I get to this one? Well, obviously this is exactly the same. I used rule 2 to manipulate this last one. And rule 2 says I can multiply a row with any old non-zero constant, and I happened to use a -1/2, which ultimately meant I was dividing by -2. So I'm going to put rule 2 here. How did I get from here to here? You guys remember? I used rule, let me see, I don't even know if I remember. I used rule, so what did I do? Oh, I used rule, in a sense, I used rule 3 again. I ended up adding them together, but technically it's like I multiplied the first row by 1 and then I added it together to end up getting rid of this term here. Let me say that again. I guess I can look at it as multiplying the second row by 1, +1, and then adding it together in order to eliminate this term here so I have the identity matrix. Please, please, please talk to me. I'm going to give another video. I'm going to make another quick video so you can see this example. Not this example, but another example again, because, I don't like the videos to be over 15 minutes. So I hope this is helpful. Feel free to talk to me in class because this is a valuable skill and it takes a little practice. I'll talk to you soon. I look forward to seeing you in class. Bye-bye.